Okay, so today we are going to discuss about new content that is called the memory device, which you can see large uh, has large application in the counter circuit. So previously we have learned about the combinational circuit. So what was combinational circuit? Here the output of the combinational circuit depends on the input of the present time, meaning suppose you have a AND gate and the output of the AND gate depends on the input that is given right now, and based on that input it will provide the updated output. It doesn't depend on the what was the previous value of A and whatever of whatever is the value of A and B right now, it gives you the output based on that. That's why it's called the combinational circuit. But there is another type of circuit which is called the sequential. So here you can see with the combinational circuit, if you add a memory device, then the combination of these two circuit, it becomes a new circuit which is called the sequential circuit. So for sequential circuit, what is the difference between the combinational one and the sequential one? It says if the memory element is added with a combinational circuit, it becomes a sequential circuit. And the basic element of a sequential circuit is the flip-flop, which is a memory device that can store at least one bit of data. But it is also made of the logic gates, but it will have a definite configuration for which it can store the data. So is there any question so far?
No, sir.
So if we talk about the flip-flop, so this is the basic diagram of a flip-flop circuit. And as we said before, flip-flop is a memory device that can store at least one bit of energy, and which is made of an assembly of logic gates, but it will have some definite configuration which is different from what we have learned so far. And basically a flip-flop circuit can have n number of inputs, but it will always provide you two output. So one output is called Q, which is the normal output of the circuit defined as Q, and the other output is called the inverted output, which is the inverted output of the key Q, so which is labeled as Q bar. So for the flip-flop circuit, you can have n number of inputs based on your system requirement, but it will always provide you two output. One is the normal output, another is the inverted output. Is there any question so far? Any question?
No, sir.
No, sir.
Okay. Now, before we can go to the flip-flop, we have to learn about the latch devices, which is the basic of the flip-flop devices. So, as you can see here, a basic latch is a feedback connection of two NOR gates or two NAND gates. So you can use either NOR gates or NAND gates to make a latch device, and the latch device can store one bit of information. So here you can see two NAND gates. This NAND gates output is connected as an input for the second one, and this NAND gate output is connected as the input of the other NAND gates. That's why it is called, there is a feedback connection. Feedback means you are taking something from the output as an input. So this NAND gate is taking the output of the other flip-flop as input. Similar to that, this NAND gate is taking this in the other NAND gate's output as the input. So what is that? What was the truth table of the NAND gate? If two inputs and your output should be A dot B, then bar, right? So 0 0 0 1 1 0 1 1. So for the NAND gate, when it is 0 0, it should be 1. This should be 1. This should be on. Only this time it should be 0. So for the first condition, it says if you put set 1 and reset 1, the output will not be changed. What does it mean? So it means if you put S1 and R1, so suppose before we are putting this 1 and 1, Q will have some value, right? That is my Q n minus 1. Since the last device is a memory device, so it will have some memory, right? And this memory, since it is a 1 bit information, so it can be either 0 or 1, right? It says if you put 1 and 1 here, the output that you will get Qn now, it will be the same as it was before, Qn minus 1. Is there any confusion? So let's see how it works. So now you are putting 1 here and 1 here, and for the Q, it can have any value previously. Suppose you can have 0 here, so your Q bar should be 1 here. Okay, phone call, I need to take it. Just give me some time. মাজার, সমস্যা নেই। কি হলো তোমাদের মিটিংয়ে? ডিএসডব্লিউর মিটিং? হুম। না আমি আসি নাই, আমার হচ্ছে ওই যে তোমার ডিপার্টমেন্ট থেকে আসার পরে আবার শুরু হয়েছে ডায়রিয়া। ওই রকমই মনে হচ্ছে। ওই হুম। কি? আচ্ছা সমস্যা নেই, রবিবারে এসে একটা বালিশ বানাইতে দিবনি, সমস্যা নেই। হুম। ওই একটা এসিতে একটা এসিতে তো ঠান্ডা হয়ে যায় না রুম, ভালো ঠান্ডা হওয়ার কথা তো। হ্যাঁ। যে হুম। ঠিক আছে, সমস্যা নেই, চাবি রেখে দাও, যখন ঘুমানো লাগে ঘুমাবা, সমস্যা নেই। ভাই আমার এই পেটে কালকে আমার এই সাভার যাওয়াটাই ভুল হয়েছে। আমি ওই কালকে রেস্ট নেওয়ার দরকার ছিল। কালকে সাভারে গেছি না এই গরমের ভিতরে, যে ওইখানে আবার বন্ধুর বাড়ি খাওয়া দাওয়া করছি, আজকে আর পেটে আবার ট্রাবল দেওয়া শুরু করছে। এই রিচ খাবার আগামী 7 দিন বন্ধ রাখতে হবে। হ্যাঁ হ্যাঁ, এনি টাইম এনি টাইম মাজার, এনি টাইম, তুমি এনি টাইম, তুমি টেনশন নিও না, টেনশন নিও না। হুম। সমস্যা নেই, ইনশাল্লাহ হবে না। হ্যাঁ, খাচ্ছি। হ্যাঁ, ঠিক আছে ইনশাল্লাহ। ওকে। honestly. So now, if in the previous state you have q equals to 0 and q bar equals to 1, then this 0 will come here and this 1 will go here. So for this NAND gate, what will be the output? You have two inputs, both are 1. So what will be the output? 0, right? And for this NAND gate, you have 0 and 1 as input. So what will be the output? 1, right? Are you following me?
Yes,
Yes,
sir.
sir.
So again, so this 1 will go as input here and this 0 will come as a input here. So the output will be again 0 and here the output will be again 1. So here you can see 0 and 1 was my previous state and the new state is following the previous state, right?
Yes, sir.
So that's why it is called no change, because what was my previous state, my present state and my future state will be as it is, as long as you put both input 1. You got my point, right?
Yes, sir.
So now if we, this 0 and 1 we just taken randomly, right? So if we want to take any value rather than 0, what will happen now? So suppose now, so now if we now consider this to be 1 and this to be 0, so let's see what will happen now. So suppose now my previous condition was like this, my q was 1 and q bar was 0. So this 1 will come here and this 0 will come here. So 1 and 0, it gives you 1, right? And 1 and 1 gives you 0. So again this 0 will go there and this 1 will come here. So 1 and 1 again gives you 0 and 0 and 1 gives you 1 here. Hello. So, ও হ্যাঁ ইমন সাহেব, আপনি যে দিয়েছেন, মেসেজ দিয়েছেন, কালকে কি আমাদেরকে কালকে কালকে কি সব সব ছাত্ররাই আসবে? মানে পাঁচটা, মানে পাঁচটা ল্যাবে, পাঁচটা ল্যাব সেটটা 5 জায়গায় থাকবে। আচ্ছা, এটা কি পরের শুক্রবারেও হবে নাকি এই শুক্রবারই শেষ? না আমি বুঝছি, আমি আমি ওইটাতে কালকে কালকে আমার সমস্যা নেই, আমি বলছি কি এটা কি পরের উইকেও হবে নাকি শুধু কালকেই শেষ? ও হুম, ঠিক আছে, আমি থাকবো ইনশাল্লাহ। হুম হুম হুম, আচ্ছা ঠিক আছে ইনশাল্লাহ, আমি থাকবো ইনশাল্লাহ। জি, আসসালাম। So what I was telling, that no matter whether the q was 0 or 1, as you can see, the next stage is always following the
Previous.
right.
Yes, sir.
So that's why it says whenever you are putting set 1 and reset 1, no matter what was the previous value of q, it will always remain the same
Same.
next and future state. You got my point, right?
Yes,
Yes,
sir.
sir.
So now let's see the second condition. What it says. So now it says if you put set 0 and reset 1, the output will always be 1. What does it implies? It implies if my previous state was 0, my next state would be 1. If my previous state was 1, my next stage would be 1. So no matter what was my previous state, the next state or the present state would be always 1,
One.
as you put s equals to 0 and r equals to 1. You got my point, right?
Yes, sir.
So now let's see how it happens. So now we are putting s equals to 0 and r equals to 1. So if you consider the first case, that's my q is 0. So q prime would definitely 1. So this one will go as input here, and this one 0 will go as input here. So 0 1, it gives you 1, right?
Yes, sir.
Yes, sir.
And 0 1, it again gives you.
One.
So this one will go as a input here, and this one will come as a input here. So 0 1, it gives you,
One.
and 1 1 gives you
Zero.
0, right?
Yes, sir.
So now this 0 will go here. So 0 0, again you get 1, and this one is coming here. So 1 1 gives you.
Zero.
So this 0 again go there. 0 0 gives you,
One.
and 1 1 gives you 0. So now as you can see, my previous state was 0, and the next couple of state, it settles to q bar settles to 0, and q settles to 1,
One.
which is this condition, right?
Yes,
Yes,
sir.
sir.
So what will happen if I take the other combination? So suppose now we are taking the second case. So suppose we are taking qn minus 1 equals to 1 and q bar equals to 0. So now for the first case, this one will come here and this 0 will go there. So 0 0 again gives you 1, and 1 1 gives you
Zero.
0. So this 0 will go there. So 0 0 again you give,
One.
and 1 1 you get 0. And similar way you will always get 1 here, and you will always get 0 here. So q is always settles to 1 for this condition, and q bar always settles to
0.
0. That's what it says. So no matter what was the previous state, if you put set equals to 0 and reset equals to 1, your qn will always be 1 for the present case and for the future state as well. Clear?
Yes, sir.
Yes, sir.
Okay. Now let's go to the next step. So for the next step, what does it says? It's if you now put s equals to 1 and r equals to 0, no matter what was my previous state, whether it was 0 or 1, my output would be right.
Yes, sir.
So let's see how it happens. So my now this condition is s equals to 1 and r equals to 0. Now for the first case, if we consider q equals to 0 and q bar equals to 1, so this 1 will come here and 0 will come here. So 0 0 gives you
1.
1 and 1 1 gives you
0.
0. Again this 0 will come here, 0 0 gives you 1 and 1 1 gives you 0. So the q settles to 0 and q bar settles to 1, right?
Yes, sir.
Yes, sir.
So if we take the second condition, so what will happen? So now suppose we are considering that our q bar was q was 1 and q bar was 0. So this one will come here and this 0 will go there. So 1 0 gives you
1.
1 and 1 0 gives you
1.
12, right?
Yes, sir.
So this one will come as an input here. So 1 1 gives you
0.
0 and 0 1 gives you 1.
Yes, sir.
So this one will go again here. So 1 0
1 1
1 1 gives you 0
0.
and this 0 is coming here. So 0 0 gives you 1, right?
Yes, sir.
This one again goes there. 1 1 gives you 0 and this 0 is coming here. 0 0 gives you 1. So as you can see, after 2 or 3 pulses, this q settles to
0.
0 and q bar settles to
1.
1. This is what is indicated in this table. Clear?
Yes,
Yes,
sir.
sir.
So now let's see the last condition. What does it says? It says no matter what is the value of this previous state, if you put s equals to 1 and r equals to 1, this qn and qn value will always be, it will be the invalid condition, meaning both your q and q bar will become 1. Is it logically viable?
No, sir. Not valid, sir.
Is it logically possible?
Impossible, sir.
That's why it is called invalid condition. So now let's see how it happens. So if you put 0 and this 0, so if you put one of the input of the AND gate 0, what will happen? The output of this NAND gate will be
1.
1, right?
Yes, sir.
As you can see, if any of the input is 0, the output is always So this NAND gate output will be 1, and as well as this NAND gate output will be 1 as well. So your in this condition your Q and Q bar will give you the same output, that is 1, which is logically not possible, right?
Yes, sir.
Yes, sir.
So whenever you are using NAND latch, we have to make sure that we are not using this condition. Is that clear?
Yes, sir.
Okay. So now suppose you have a NAND latch, SL latch, and you have been given this input set and reset. Now you need to draw the output. So for the output Q and Q bar, what will I suggest you? I suggest you to take some initial state. You can assume it. So suppose in initial state Q I consider to be 0. So Q bar will be 1, right?
Yes, sir.
So now for this part S is 0 and R is 0. So if this both are 0, what will be the condition? So both will be 1, right? So Q will go to 1, and Q bar, it was previously 1, so it will retain its state. So now up to this part, if you can see, set value is 1, reset value is 0. So 1 0 gives you output 0, right? So here Q bar goes to 0, sorry, Q goes to 0, and Q bar remains 1 because it goes to 0. So Q bar will be 1. So now up to this part both are 0, right? So
Yes, sir.
0 means it's an invalid condition, and Q bar will be
1.
so it will again go to 1, and it will keep its state. Now for the next state, this is 0, this is 1. So if you see 0 1, it gives you 1.
Q1.
So it will be 1, and this thing it will go to
0.
0. Again up to this part, here we can see both are
0.
so if it is 0, it means
Q
this
will be 1.
1 and this should be 1 as well. Again up to this part, here you can see your S value is 0 and R value is 1. So 0 1 gives you 1, right?
Yes, sir.
So this will be 1,
0.
and this will go to 0. Again up to this point, this is 0 and this is 0. So it will be the invalid.
1.
So both will be
1.
at 1 state. Now up to this point, it will be 1, it will be 0. So 1 0 gives you 0. So Q will be 0, and then Q bar will be 1, and up to this part both are 0. So if both are 0, this is invalid condition, meaning this will go to 1, and as well as this will go to 1. That will be the output. Is there any confusion?
No, sir.
Is there any portion that needs any clarification? Okay. So similar to the NAND gate, we can make SR latch using two NOR gates as well. And for these NOR gates, the truth table that we get, it will perform the same thing but in a different SR combination. For example, for the NAND gate, if you put 0 0, what was the output?
Invalid.
Solution, right? But here, if you put 0 0, the output will be no change. Similarly, if it is 1 0, the output is 1. If it is 0 1, output is 0. And if it is 1 1, it is invalid, meaning that for this condition, your Q and Q bar both will become 0.
0.
So I can show you one combination out of this 4 combination. So whichever you want to see.
Third one, sir.
You mean this one?
Yes, sir.
Okay. So now it says if you put s equals to 0 and r equals to 1, no matter what was my previous condition, qn becomes 0, qn becomes 0. This is what it says. So now you putting set equals to 0 and reset equals to 1. Suppose we are considering the first case, so we are taking q equals to 0, then q bar would be 1. So now this 0 will go here and this 1 will come here. So for the NOR gate, what was my truth table? So 0 0 gives you 1, 0 1 gives you 0, 1 0 gives you 0, 1 1 gives you 0, right?
Yes, sir.
So again 0 0 gives you
1.
1 and 1 1 gives you
0.
0. So this 0 will go as an input here and this 1 will come as an input here. So again 0 0 gives you 1 and 1 1 gives you 0. So as you can see, this q will settles to 0 and q bar will settles to
1.
right.
Yes, sir.
Now if we take the other condition, like now suppose we are considering q is 1 and q bar is 0. So now this one will go here and this 0 will come here. So 0 1 gives you
0.
0, right?
Yes, sir.
And 0 1 gives you
0.
0. So this 0 will come here and this 0 will go here. So 0 0 gives you 1, right?
Yes, sir.
And 0 1 gives you
0.
so this one will come here and this 0 will go there. Again 0 0 gives you 1 and 1 1 gives you 0. So this 0 will go here and this 1 will come here. So 0 0 again gives you 1 and 1 1 gives you 0. So now here you can see this q bar now settles to 1 and q becomes
0.
permanently 0, right?
Yes, sir.
Yes, sir.
Is there any confusion?
No, sir.
So you will have your quiz in this coming Saturday, 4th of May, and your midterm will be on the 9th. Okay?
স্যার মিডটা 11 তারিখে দেয়া যাবে?
No, mid will be on 9th. We have postponed it for so many occasions, so we don't know whether they will switch to the online mode again in near future or not, so we'll not take that chance. So similar to that, if you see that, so we have the truth table for SR latch made of two NOR
No.
gate. So for this case also, if we consider Q and Q bar, I am considering my initial state for Q is 0. So the initial state for Q bar would be 1.
1.
So now here up to this point, you see S and R both are 0. Both are 0 means
No.
output will be no
Same.
change. No change means 0 will be 0 and 1 will be 1. So up to this point, set is 1, reset is 0. So 1 0 gives you output 1. So this Q will become 1 and Q bar will become 0. So now here both are 0, meaning there will be no change. So 1 will be 1 and 0 will remain 0. From this point, this is 0 and 1. So 0 1 gives you output 0. So here it will switch to 0 and this will switch to 1. Again, here you can see this is 0 0. 0 0 meaning no change. No change means 0 will remain 0 and 1 will remain 1. So here you can see set is 0 and reset is 1. So 0 1 gives you output 0. So Q will be 0 and Q prime will be 1. Again, up to this point, both are 0. So it means no change. No change means 0 state will remain 0 and 1 state will remain 1. And here you can see 1 0. So 1 0 gives output 1. So here Q will become 0 and Q bar will become, sorry, Q will become 1 and Q bar will become 0. And for the last case, S and R is 0, 0 meaning the output will be no change. So 1 will be in 1 position and 0 will be in 0 position. That will be your output. Is there any confusion for this graph?
No, sir.
Okay. So now, previously we saw two latch gate that has two inputs, S and R as input, and they have two output, Q and Q bar. But in order to have more controllability, we can add another input which is called enable input. So if you see this dashed line, this is the SR latch we just studied, and this portion is the added section that is used for the extra control that we might require for several applications. So previously we have learned about the enable condition. Can you remember where we use that one?
To turn on and off.
Flip. We use that in multiple.
Multiplexer. Yes, sir. Max.
So now for this section, what this, since this is NAND gate, flip latch gate, so for NAND gate what was my condition? So now I want to add some inputs. So this is my first three, S, R, and suppose we are adding another one here, enable. So these are these three inputs, and suppose we are giving this input and this input some name. So suppose this is my S1 this is my R1, and this will be my final output Q. So now if you put enable 0, enable 0 means this 0 will come here and this 0 will come here. So now tell me, if one of the input of the NAND gate is 0, the output will be 1, right?
Yes, sir.
Here you will get 1 and here you will get 1. So what was the flip-flop output? If both are 1, there will be no change, right?
Yes, sir.
If it is 0, 1, it becomes 1. If it is 1, 0, it becomes 0. And if it is 0, 0,
Invalid.
the output is invalid, right?
Yes, sir.
That's what we get, right? 1, 1, no change. 0, 1, 1, 1, 0, 0, and 0, 0, invalid. So now, if enable is 0, so no matter what is the value of S and R, the output here would be 1, 1, right?
Yes, sir.
And if it is 1, 1, what will be the condition?
No change.
No change, right? So here you see, if enable is 0 and S or R, whatever its value, the output would be
No change.
right.
Yes, sir.
Now suppose your enable is not now 0, it is 1. Enable is 1. So if your enable is 1, then what will be the output of this NAND gate? What will be the output of this NAND gate?
Zero.
So it's 1. So output of this NAND gate should be S multiplied by 1 bar, right?
Yes, sir.
And this output should be R multiplied by 1 bar. So we can write it as S bar and
0.
R, right?
Yes, sir.
So now if my enable value is 1, S value is 0, R value is 1. So here we can see, then since if you give here 0 and here 1, then this value will be 1 and this value will be 0, right?
Yes, sir.
So this value will be 1 and this value will be 0. So for 1, 0, what will be the output? 0, right?
Yes, sir.
So it will be 0, as you can see from here. Now if enable is 1 and you are putting 0, 0 here, that's mean this should be 1, 1, right? Because it's a bar here, right?
Yes, sir.
So for 1, 1, what is my condition?
No change.
No change. So for this it is also no change. Here you can see, if it is 1 and both are 0, what will be the output?
No change.
Now again, if you put 1 and you put here 1 and 0, so it means they will be inverted here because S bar and R bar. So it will be 0 1, and for 0 1 what is the output?
1.
1. So here you can see the output will be 1, right?
Yes, sir.
And for the last condition, if you put
S R E equals to 1,
1 1 1, so it will be
0, 0.
0 0, right?
Yes, sir.
So for 0 0, what is the condition?
Invalid.
Invalid. In this book it is defined as
Inter
intermediate.
Yes, sir. In
This both represents the same thing. So do you understand where this truth table come from?
Yes,
Yes.
sir.
So now if you understand that thing, now let's do this output diagram. So for this output, we have to keep remembering that as long as my enable is 0, the output will be
No change.
no change, right? So now if my Q is there and Q, sorry, Q bar is here. So now we are considering Q to be 0 and Q bar to be 1 up to this point. And now from here to here enable is
0.
0, meaning
No
there will be
change.
no change, right? So 0 will remain 0, 1 will remain 1.
1.
Now here to here you see up to this point S is 1, R is 0. So S is 1, R is 0, output would be
1.
1, right? So here output will be 1 and Q bar would be 0, right?
Yes, sir.
And from here to here enable is again 0. The enable 0 means
No change.
No change.
no change. So 1 will remain 1 up to this point and 0 will remain 0 up to this point, right?
Yes, sir.
Yes, sir.
Now from this part S is 0, R is 1. So S is 0, R is 1, output should be
0.
0. So it will remain, it will become 0 and this will become 1. And from here to here on, your enable is again, so 0 will remain 0 and 1 will remain 1. Now for this part, as you can see, S is 1, R is 0. So S is 1, R is 0 gives you
1.
1. So here output will become 1 and this will goes to 0. And from here to here, enable is again 0, meaning 1 will remain 1 and 0 will remain 0. And up to this point, both are 0. So
No change. No change.
no change. So 1 will remain 1, 0 will remain 0. And here to here, enable is 0, meaning no change. So output will remain as it is. Is there any confusion? Any confusion?
No, sir.
Okay. So similar to that, we can make the same circuit using two
NOR gates.
NOR gates. So this is my SR latch and this is the extra circuit added to have more controllability. And as you can see, this truth table will be somewhat different than what we have learned in the previous slide. So this is your homework. You can try it at home, and if you have any question, you can ask me next class. Okay.
Yes, sir.
Okay. So now let us go to the flip-flop section. So what is flip-flop and what is the basic difference between the latch device and flip-flop? So for the latch device, you can see you can control it using some enable signal. But for the flip-flop, it is also a energy storage element that can have its output state changed only on the edge of a control signal, clock signal. So for the flip-flop, you have to put another signal which is known as the clock signal. And there are two types of flip-flop. One is called positive edge triggered, another is called negative edge triggered. So positive edge triggered means this flip-flop will only work on the positive edge. Positive edge means when the value is changing from 0 to 1. It will work only on that portion. And for this flip-flop, it is called negative edge flip-flop because it will work on the negative edge when it is switching from 1 to 0. So as you can see, these are the same truth table that we have learned for the SR latch. The only difference is that this clock. So previously, whenever you give 0, 0, 1, 0, 0, 1, 1, 1, you can have the output. But for the flip-flop, you will only have it work whenever you give the positive edge or the negative edge. Is that clear? So how it works? Let's see how it works. So suppose we are considering this positive edge flip-flop and this is your input S and R. So now this is your clock signal. So we have to only consider this edge, this edge, this edge, this edge and this edge for operation. So now if we consider Q and Q bar, and if we take Q to be 0 until this point and Q bar to be 0, Q bar to be 1. To be 1 until this point, it will remain as it is until we get the first positive clock, and 1 will remain until the first positive clock, and just before the first positive clock we have to see what was the value of S and R. What is the value of S and R?
0,
0.
0, 0. 0, 0 means
No change.
no change. No change means it will remain 0 until the next positive clock, and it will remain 1 until the next positive clock. And just before this positive clock, what was the value of S and R?
R
1 0.
0,
1, 0. So if you give 1, 0, what was the output? What should be the output?
1.
1. So now, as soon as it gets the positive clock, it will switch to 1 and remain 1 until it gets the negative positive clock, and this Q bar will switch to 0. You got my point, right?
yes,
Yes,
sir.
sir.
So just before this positive clock, what was the value of S and R?
1,
0 1. Yes,
So
sir.
for 0 1, what should be the output?
0.
0. So it will just, it gets, whenever it gets the positive pulse, it will switch to 0 and remain to 0 until it gets the negative, sorry, next positive pulse, and it will switch to 1. And now just before this positive clock pulse or positive edge, what is the value of S and R?
1 0.
1 0. So if you get 1 0, what would be the output?
1.
1.
1. So it will switch to 1 and remain 1 until the next positive edge. And now just before this positive edge, what is the value of S and R? Again 1 0.
0.
So it will remain to 1 until it gets the next positive pulse, a positive edge, and it will remain 0. You get my point, right?
Yes, sir.
So now this same pulse, it is, if it is applied for the negative edge triggering flip-flop, so how the output will change? So for the negative edge triggering, what we should consider?
Downward arrow.
Portion, this portion, this portion, this portion, and this portion, right?
Yes, sir.
Yes, sir.
So now if we take Q and Q bar, and if you consider Q to be 0 and Q bar to be 1, so it will remain 0 until unless it gets the first negative pulse. And whenever it gets the first negative pulse, what was the value of S and R just before this negative pulse?
0 0.
0 0. So 0 0 gives you
No
change.
change.
no change. So it will remain 0 until it gets the next negative pulse, and this will become remain 1 until it gets the next negative pulse. So just before this next negative pulse, what was the value of S and R?
1 0.
1 0. So 1 0 gives you
1.
1.
1. So here it will switch to 1 and remain 1 until next negative pulse, and it will switch to
0.
and remain 0 until next negative pulse. So here to here you can see what is the value of just before this negative pulse, what is the value of S and R?
0
0,
1.
1.
0 1. So 0 1 gives you
0.
0. So it will switch to 0 and remain 0 until next negative pulse, and it will switch to 1 and remain 1. So now here if you have the negative pulse, just before the negative pulse, what is the value of S and R?
1 0.
0.
1 0. So 1 0 gives you again
1.
1. So it will switch to 1 and this will switch to 0 until unless it gets the last negative pulse. And just before this last negative pulse, what is the value of S and R?
1,
1
0.
0.
1 0. So 1 0 gives you
1.
1.
again 1. So it will remain 1 until the next negative pulse, and it will remain 0 until the next negative pulse. So you understand how these two flip-flop works, right?
Yes,
Yes,
sir.
sir.
Is there any question so far?
No, sir.
So we will end our lecture today here, and from next class, which will be on Monday and Tuesday online, so we'll start from here, okay?
Yes, sir.
And as I said, you will have your quiz on Saturday, followed by the midterm on the 9th of May.
স্যার মিড টার্মের সিলেবাসটা তাহলে কি হবে?
Whatever we have covered until 20th of April,
ওকে স্যার।
Marks.
up to the multiplexer circuit.
স্যার
স্যার এই
আমাদের কুইজ
স্যাটারডে কুইজ হবে?
হ্যাঁ,
স্যার থার্সডেতে নেওয়া যায় সামহাউ?
no, next Thursday তে midterm হবে.
ও আচ্ছা আচ্ছা।
স্যার 11 তারিখে কুইজটা নেওয়া যাবে, কারণ
নো,
যে ফ্রাইডেতে 7টা পর্যন্ত
না না না, এগুলো করা যাবে না, কারণ যে কোনো সময় আবার অনলাইনে সুইচ করতে পারে। সো আমরা এই রিস্ক আর নিব না। এভাবে পিছাইতে পিছাইতে ঈদের পরে তোমরা অনেক পিছাইছো, সো এটা আর পিছানো যাবে না।
স্যার অনলি কেএমএফ থাকবে তাই না স্যার?
কি বুঝি নাই?
স্যার শুধু কেএমএফ থাকবে তাই না কুইজে?
হ্যাঁ, the syllabus for quiz is KMAP, and for the midterm what we have covered until the multiplexer circuit, or sorry,
Sir,
including multiplexer circuit.
স্যার কেএমএফ কি 3 ভেরিয়েবলের উপর আসার কোনো চান্স আছে?
It can be up to 6 variable.
স্যার আমাদেরকে